All right. Well, that was fun. Little break in the middle of class. All right, so we got 20 minutes, right? Or so, 40 minutes, right? Just under 40 minutes. I was watching the time so closely. We lost half an hour, didn't we? All right. So, all right, let's do what we can with 5.2 and 5.3. Did we just do this when I'm losing track? Did we? Oh, yeah. We did it, but I didn't do the domain and range and graph and stuff, huh? We just found the inverse and that was it. Okay, I remember now. So let's do that. So the inverse is the cube root of x plus 2. That's right. That's where we were at before we were so rudely interrupted. All right, so okay, so we have the function and we have the inverse function. And we want to, first off, they're going to ask us domain and range for both of them, and then we're going to graph them. So let's go ahead and do that. How do you find the domain? You guys and gals are domain pros now. How do you find the domain when you're given an algebraic form? Like, letters and stuff. What do? Remember, it's just about looking for the two trouble spots, right? We had two ways that you identify trouble spots. Denominators can't be 0. And inside of an even root, just an even root, 2 root, 4 root, can't be negative, right? It must be greater than or equal to 0. Well, we don't have either one of those here. We don't have roots. We don't have denominators. So then what's the domain? All reals, right? Or you can go negative, infinity, positive. I don't care in a test. Either one's good. They both mean all numbers are okay. So that's the domain of the original function. What's the domain of the inverse function? Same test, meaning denominators can't be 0, but we don't have any denominators. And roots, but this is an odd root. Odd roots are okay. So it's all reals, isn't it? It's the same answer. It's all reals, negative infinity, positive infinity. Either one. Does that make sense? If that was in it, you guys okay? You guys know that odd roots you can have a negative number. Like think about the odd root of the third root of negative 8. That's fine. It's just negative 2, huh? Because negative 2 times itself 3 times would be negative 8, huh? So odd roots are fine. You could never have the 2 root of like negative 4 because there's not any number times itself. No number twice is negative. No number 4 times is negative, right? But odd are fine, aren't they? Anyway, so that's just a long way to say odd roots are fine. We don't care about odd roots. It's just even roots that we say must be positive only, greater than or equal to 0. So anyway, the domain is all reals and for both. Now, they're also asking me for the range. Now, I bet you guys can figure this out really without me saying anything. Remember, functions and their inverses, what this section is all about. Everything swaps, huh? We're switching everything. So we're switching x and y. We're switching domain and range. We're switching everything. So how are we going to find the range of f inverse, do you think? It's going to be the same as what? As the domain of f. Same as domain of the original. Does that make sense? The range of f inverse is the same as the domain of f. And over here, when I come over here to do the range for f, what's the range of f going to be the same as? Same as the domain of f inverse, right? This guy goes there, and this guy goes there. Does that make sense? Domain for one is range for the other. Domain for one is range for the other. Because it's just a switching. Inverse functions just switch everything. So anyway, in this one, it's everything is all reals, huh? But in other problems, it'll be more helpful. This one is just everybody's all reals, all domains, and all ranges. Good with that? All of that. So now the last part D, we need to graph these two. So if you've got all that down, I'm going to go over here to part D and see if I can graph them both. So start with the original function, x cubed minus 2.
Is it always like that? The domain will be the range for the inverse?
Yeah, it's always that way. The domain for one is the domain for the original is the range for the inverse, and the domain for the inverse is the range for the original. Always. All right, so how do we graph? They want me to graph the original function and the inverse right on the same axis system. how do we graph the original function x cubed minus 2? You've graphed that back in the first part of the course, huh? Remember how we graphed that with the xy table kind of thing? We find the center point and one other point. Remember that whole process? How do we find the center point?
0.
Yeah, that would just be plug in 0. And y, or f, will equal what? Negative 2. So that would be over 0 down 2 right there. And then what do you do to find, that's the center point. What do you do to find the other point? Add 1, so positive. Plug in 1, what do you get? Y equals 1 cubed minus 2, which is negative 1. Yeah, so over 1, down 1 right here. So there we have the 2 dots for the original function. What does the general graph look like through those 2 dots? Remember what x cubed looks like? It's the snake. Remember, that's the odd power snake, the vertical snake, the up and down snake. So now let's do the inverse function. Inverse function is the cube root of x plus 2, right? So now how do we do that? You know what you could do is you can just reverse the points, huh? In other words, whatever x, y you had in the original function, just swap them. Minus 2, 0, minus 1, 1. Remember how inverse functions just switch x and y? So you don't even have to mess around with plugging anything in. You can just grab the other ones we had over here, swap them, swap them. So back 2, up 0, there's that dot. And then back 1, up 1, there's that dot. So back 2, up 0, back 1, up 1. Good. There's the 2 dots for the inverse function. And then the inverse function is a cube root. What do cube root graphs generally, what general shape am I going to pass through those 2 dots? Remember what cube root ones look like? Cube root of x is the sideways snake. Oops, I kind of missed. Yeah, remember, third power is up and down snake. Cube root is sideways snake. Just like x squared is up u and root of x is a sideways. Remember that rooters always go sideways and the powers always go up, down. So that's a sideways snake. So we go like this. Like that. So that's a sideways snake for the inverse. And it's an up-down snake for the original. And notice what we see about them and the diagonal line. See how they end up being reflections across the diagonal line, like we said, always happens for functions and their inverses. So there we go. We did like everything for that question, right? We found the inverse, we did the domains and the range, we graphed them both, and noticed that they're reflections. It's kind of nice just to see everything we've learned kind of agreeing with each other, all the facts. Did you have a question, Carissa?
What would he do some of these graphing ones like right now that you just did, the inverted?
Yeah.
Is that what it's called?
Yeah. Mm-hmm.
I was trying to look.
All right. So there's the original function f. Let's call it f or y or whatever you want to call it. Okay. So first thing is, can you find the inverse function? Go ahead and give that a try. Find the inverse function. Remember the 2 steps for finding an inverse function when you have algebraic form? Switch x and y, solve for y. Right? Where's the y, by the way? The y is the f. Right? The y is the f. All right. So this is our y. So this is y. So switch x and y, so this will become x out here. Oops. So x on the outside, y there. So x and y swap. Step 1. Invert or switch x and y. We did. We switched x and y. And then what's step 2? Solve for y. So now solve that for y. So how do I solve that for y? What do you do when you've got like a whole number or a whole letter on one side and a fraction on the other? You know, the easiest thing to do is really just put that over 1 and then just diagonal, cross multiply. I think that's about the easiest way to go. So you just get x times 4 plus y is 1 times 2, and then distribute. Does that make sense what I'm doing? Everybody see the steps I'm taking there? Just diagonal. And then distribute. So we get 4x plus xy. 1 times 2 is just 2. Good to there. So we switched x and y, inverted x and y, and then we solve for y. That's how you always find the inverse function. Just 2 steps. Switch x and y, invert x and y, and solve for y. How do I finish solving for y? Because y is the function, right? So that'll be the new inverse function since we have inverted x and y. So yeah, just grab that 4x and jump it over, or subtract 4x from both sides. It becomes a negative 4x over there. Last step to get y alone. Divide by the x. Can I cancel these x's over here like that? Not allowed, right? Everybody okay with that? Why not? What's causing the problem? Why is that not allowed? The minus sign. Yeah, everybody catching what I'm saying? Real helpful when you go to calculus. Pluses and minuses glue things together, right? Like shopping at Costco, package deal, right? So in other words, when you see that minus up there, 2 minus 4x, just think that's glued together, which means if you want to buy part of it, you go like that, and you buy the whole package, or you don't touch it. It's all or nothing. They're glued together. It's a package deal. We can't buy it all, so we buy nothing. So those x, you can't cancel just the x part. It's all or nothing, so we do nothing. So it just stays like that. Pluses and minuses are glued. All right, so anyway, there's our inverse function. That is the inverse. So we have the original function, we found the inverse. Then they're going to ask you for the domain. That'd be pretty easy, right? What's the, let me go back to the original. I think you can do that easy. What's the domain of the original f here? Yeah, denominator cannot be 0, so x cannot be negative 4. Anything but negative 4 for the domain of the original. And then what's the domain of f inverse? Denominator cannot be 0, huh? And then remember the swap-a-roo rule? The domain of f becomes the range of f inverse. And the domain of f inverse becomes the range of f. So we just swap them. We say, okay, this is the domain of f. Come down here, this is the domain of f inverse. What's the range of f inverse? Well, it's this. It's the domain of the other one. Domains and ranges just switch, don't they? Is that good? And up here, the range of the original f is x not equal to 0. It's the domain of the inverse. So domains and ranges switch. So basically, you just find the domain for both of them, and then those just switch to be the ranges of the opposite one when it comes to inverse functions. We good?
When you're going to identify, when you're always trying to identify an inverse function, it's going to be that f with the negative 1, right?
Yeah, f to the negative 1 is the symbol for inverse function. That's right. All right. Questions on that? We all good? You can do 23 here. You can do any of them. All right. So f, the original, is 6x plus 6 over 9x minus 5. Okay, so can you find the inverse function? So switch x and y, you know the two steps, right? Switch x and y. So step 1, switch or invert x and y. So x. So both the x's become y's, and the y becomes x. They simply trade roles. X's become y's, and y's become x's. like that, good for the first step, just switch x and y. And then step 2 is going to be a lot of work. Step 2 we have to solve. So what should we do to get going on step 2? That's the first part of that. Yeah, same thing as last time, huh? Cross multiply, yeah, just put that x over 1 and go diagonal, diagonal. So step 2 is solve for y. So it'll be x times 9y minus 5 is 1 times 6y plus 6. Good to there so far. Just diagonal, diagonal. Like that, distribute. 9xy minus 5x. 6y plus 6. Good. Now, this is where the trick comes in. This is where it gets a little harder. Everybody good to there so far? Just been pretty standard up to there, right? Just switch x and y, and then to solve for y, we do, put it x over 1, cross multiply, diagonal, diagonal, distribute. Now, here's the trick. What are we trying to solve for? Y. Where's y? Here and here. 2 places. How do you solve for something in 2 places? If y, or whatever letter you're trying to solve, this will come up a lot this semester and in calculus a lot. And I think we did it one other time if I'm remembering right. I could be wrong. Anyway, what do you do when y is in 2 places? This is an issue that will come up frequently. The thing you're trying to solve for is in 2 locations, right? It's here and here. That's a pain. What do you do when the thing's in 2 places? You get them on the same side, and you factor out the y and divide. So in other words, this term and this term that both have y in it, we must get those guys on the same side. Doesn't matter what side, right side, left side, whatever. Just get them on the same side and everything else, other side. So I'm going to grab this guy and jump this way. I'm going to grab the minus 5x and jump that way. That way, see my plan? That way I'll have both the y terms on the left and the terms on the right that don't have y. Now, you know what happens when something jumps over the equal sign, right? What changes? The sign in front. I'm just doing a shortcut. I'm basically adding 5x to both sides and subtracting 6y from both sides in a quick way. So 9xy minus, that'll become a minus 6y when it jumps over. And the negative 5x, when it jumps over, will become a regular or positive 5x, huh? See what we did there? So notice how I've got both the y terms on the same side? So this is real standard. You have to do this a lot this semester and especially in calculus. Next semester if you take that. So you got 2 places, get them on the same side, and then factor out the y. Notice I didn't even factor out a 3. You could have taken out a 3, but I don't really care. I'm just focused on the y. I'm just taking out the y, right? Get them on the same side, factor out, and now you can just divide, huh? Just divide both sides by 9x minus 6. Boom. Like that. There's my answer. What is that? That's the inverse. Everybody see all that? That makes sense? These steps here. So I always put one of those on the next test. No secrets with me. I want to make sure you can do that algebra. I'm trying to get you ready for calculus. Trying to give you my stamp of approval at the end of the semester. So I got to put ones like this on the test. Make sure you're ready to go. I wouldn't be doing you any favors if I moved John, you weren't ready. So, everybody good with that? Any questions I can answer? This is especially where I want to be helpful this semester, is all this algebra mess. I know that's what bogs people down. Is that okay, those steps?
So that's your final answer.
That's your final answer because I got y alone. Because these canceled, so y is all alone. So we switch x and y, solve for y. That required cross multiply, and then we had y in 2 places. We got them on the same side, factor out, and divide. That's what you always do. All right. So 26, okay. So 26 is saying find f of negative 5 from the graph. There's no equations, there's just a picture. So how do we do that? Can you tell what the answer is? This is an x value, and what comes out is a y value. They're saying, look at the graph, find the x value, negative 5. There it is. X value -5. What's the y value that goes with it? Also -5. There's part A. Part B says what's f of 4? So x value 4 on the graph. Where is it? Here? Yeah, x. And it goes with the y value 5. That's all they want you to do. Now, for C and D are talking about inverse, huh? F inverse. So remember what it means to be an inverse function. You've inverted x and y, huh? So if normally what's in the parentheses is x, what is it for an inverse function? That's y. And what's out here is x. So they're saying look on the graph and find the y value of 0. Well, it's right there. And what is the x value that goes with it? -4. So those are just graph reading. They're just making sure you're getting the idea of functions and their inverses. Is that good on that? All right, so we have f, or y, equals x squared minus 1 over 4x squared. Can you find the inverse? Let's just do that. The rest is easy. Find the inverse. So how do we find the inverse function? What do we do? Switch x and y and solve for y. Yeah, so go ahead. Both those x's become y and the y becomes x. You guys okay with going like till 50 after, since we kind of had our 10-minute break for a while? If you need to take off, feel free. You know, I'm going to go ahead and go to 50 after, and it'll be on the YouTube, so you can grab it if you have an appointment or something like that. I just want to give you as much as I can, since we did the fire thing for nothing, like it always is. I've never really been in a fire, but I've been in lots of drills. I'm sure you feel it. I just get sarcastic after a while. One time I really did hold a class in for a while. I'm like, no, guys, it's a drill. Because they were, oh, I know, I was teaching years ago. It was right after 9/11. It was right after 9/11, like a month after. You know, they were fire drilling all the time because they just wanted everybody ready. You know, remember, I don't know if you remember all that around that time, if you were old or like I was at that time. Anyway, I was teaching at Stanislaus State up in Turlock. Anyway, and they were the month after, they were just fire drilling us all. Then they were sending emails, we're going to fire drill 2 times this week, and they're just making sure the campus was ready, you know. And it was just killing my lectures. So I remember one time I'm like, guys, let's just keep going. We're okay. And these like official people came to the door. There's people with the, you know, the hall monitors, the glorified hall monitors. And they said, what are you guys doing? You let those students out of here. I'm like, all right. I just got tired of it. All right. So switch x and y. Step 1, switch or invert x and y. So they trade. So this becomes x out here, y in there. And then same thing, cross multiply, right? Got to solve. Step 2 is solve. Step 2, solve for y. Because we've inverted, so now the y will be the inverse function when we solve for it. So go ahead and do that. Put the x over 1, diagonal. X times 4y squared is 1 times y squared minus 1. Like that, is that good? Diagonal. That's what we always do when we got 2 fractions, right? And that probably looks kind of weird. X, 4, y squared. Just stick the 4 in the front. You don't have to. It just looks better. And then the 1 distributes and really does nothing. We good to there. What are we trying to solve for? Trying to get y alone. So what do? It's in 2 locations. Here we are again, right? The thing we're trying to solve for, y, is in 2 locations. So get them on the same side, factor out the y squared, and divide. And then at the end, you'll have to root it to turn it into a normal y, right? But at first, it's the same thing as whatever 23 was, where you got it in 2 locations. So whenever you have 2 locations, get those on the same side, factor out, and divide. And then root. Right, so I'll grab this one and jump him over here. So I'll have 4xy squared minus y squared is negative 1. Does that make sense? See how that puts both the y terms on the same side? And now I can factor y squared out and divide. Let's bring it up to here. So we have 4xy squared minus y squared negative. So definitely practice this. This isn't easy. It's an important skill to get the hang of, and you'll use it a lot in calculus. So factor out the y squared. Leaves a 4x minus 1 when I factor out the y squared. That's how we always do it. Whenever the thing we're looking for, the thing we're trying to solve for, is in two locations, get them on the same side. I got the two y squareds on the same side. Factor out and divide. So the next line, I'll divide. Boom. So now I have y squared is negative 1 over 4x minus 1. But I want regular y. I got y squared alone, but I want regular y, so I root it, huh? So now we root it. And so we root it like that. The rooting cancels the squaring. And do I have to do plus or minus? Plus or minus. Like that. Roberto, you missed all this excitement. We had a fire drill. We all evacuated for half an hour and came back in. Somebody pulled the thing just for fun, I guess. It's the rumor Carissa's telling us, yeah.
That was what the lady
I'm sure you're right, yeah.
Because I was talking about it, she was like, there was no fire, somebody just spilled it.
Yeah.
I was like, oh.
All right, so everybody give me there. I rooted both sides, and the rooting cancels the squaring. And so we get y equals plus or minus square root of negative 1 over 4x minus 1. Good to there? Yeah, so we do need the plus or minus for an even root. Whenever you do the root on an even, when you put the roof on for an even root, you got to do plus or minus. Odd roots, you don't, right? We've seen that difference, right? Now, plus or minus, are they both answers? Do we enter them in on the question? Actually, no. It's only the plus. Why is it only the plus? Because they said so. Look up here. Did you notice that little condition they're putting there? They said we only want x values greater than 0. X positive only. In other words, right? Greater than 0 is positive, right? They said we only want x positive. So we only want the positive. We don't want the negative. Now hold on. That's y. Y equals negative. Why would I get rid of y equals negative if they're telling me they want x positive? What's that to do with y? You know the answer. It's because it's the inverse, right? This is the original function. X means the inverse is y. Whatever's true of the original x is the inverse is y. So if they say you want the original x positive only, that means the inverse is y is positive only. That's the reason. It's just the plus. All right, we good?
So when you type in your answer, you would just...
Yeah, you wouldn't put anything in front of the root. Yeah, you would just put nothing, and that's positive. Yeah, exactly. So really, if you just forgot the whole plus or minus thing, you're fine, in other words. Turns out. All right. To explain them. There's a good questions. For sure one of these is on the test. You can see it on the practice exam for next Tuesday. All right. So I'll give you a table, and I'll say, hey, look at that table and tell me if that thing is linear, exponential, or neither. That's a valuable skill to start to distinguish between these kind of things. How do you know? Basically, look at the y values, the f values, same thing, and look at how they go up. That adds 6, adds 12, adds, 12 again, adds some other big number, 24? 24, right? Now, how does that, if it's adding the same number, it's linear. Why? Because that's what a linear function does, right? As x goes from negative 1 to 0 to 1 to 2, right? Negative 1 to 0 to 1 to 2 to 3, right? Anything linear goes up, the heights go up by the same amount every time, don't they? For any line, the y values add the same amount every time. So are these the same number every time? No, not linear. So this one's not linear. Now we're going to do the exponential test. I'm doing them one at a time. First I tested for linear. No. This is not, it must not be a linear function. If you did those dots, they wouldn't go up in a line. You can put them on a graph if you want. They would not go up in a straight line because y is not going up by the same amount every time. It's not adding or subtracting the same amount every time. So let's go back now. So it's not linear. Now, it's okay if I just erase that. Well, I'll just rewrite it over here. Let's decide if it's exponential. Excuse me. Sneeze? Yes, eventually. All right, so -1, 0, 1, 2, 3. What was it? 6, 12, 24, 36, 60. Okay, now the other test is it multiplying the same number. What's it times in there? 6 times what is 12? 2. 12 times what is 24? 24 times, no, I don't know, it's not 2, it's 1.5, turns out. But all I care is it's not 2, and it's not 2. So it's not multiplying the same number. If it was multiplying the same number, that'd be exponential. So I'll just say if it's multiplying the same number. And by the way, multiplying is the same as dividing. Because if you multiply by upside down, that's dividing, right? And adding is the same as subtracting. Because if you add a negative, that's subtracting, right? You want to think that way from now on in math. Adding and subtracting are the same thing, right? Multiplying and dividing are the same thing. Dividing is just upside down multiplying. Subtracting is just negative adding, right? They're the same. So whenever somebody says something's true of adding, they mean adding and subtracting. Multiplying means multiplying and dividing. So anyway, if your multiplier divides the same number every time, then you're exponential. But this one is not exponential. So this one's neither. It's neither. Didn't do either one. So if you add, subtract the same number, you're linear. If you multiply or divide the same number, you're exponential. All right, that's our first. All right, let's take a look. Yeah, what's happening from jump to jump? Is it multiplying the same number, adding the same number? What's it doing? Times 10, times 10, times, even the first one is times 10. 1/10 becomes 1, huh? Exponential. Done. Multiply the same number every time. Put that on your 3x5 card, for next Tuesday. Go back. We gotta say more than exponential. Thank you. So I've got to say what kind of function is. Okay, so if it is exponential, then it's of the form y equals a times b to the x. I'm going to give that general form. And what are that? And what are those? The b is the number multiplied each time, and the a is the number next to x0. So, did you track with all that? So it's y equals something times something to the x. Because it's exponential, so x is up there in the exponent world. Exponent land. All right, so what's the a? What's the number in the very front? Well, it's whatever number's next to x0. What's next to x0? 1. A is 1. Let me see how I'm coming up with that. It's always whatever number is next to x equals 0 in the table. Why? Because if you plug in x equals 0, what is anything to the 0 power? Anything to the 0 power is 1. Yeah, so this part just becomes 1, and so y just equals a. So you see, whatever you're getting when you plug in 0 for x is a. The y value is 1, so the a is 1. What's the b? The b is the number you multiply each time. What are we multiplying each time? This is b, and a is right there. B is 10. So it's 1 times 10 to the x, or you could just say 10 to the x, same thing, since it's just a 1 in front. So that's the answer. That's the exponential function that's producing those table values. We kind of worked backwards from a table to a function. Is that good? I'm glad Carissa caught that. Okay, try that one, guys and gals. Try that. See what's happening over there. Take your calculator if you're not sure. Skip if that fraction one bugs you. Skip it. Start with the second one. See if it's adding or multiplying. It looks like multiplying, right? Those are big numbers. See if and how do you figure multiplying? You divide. Just take 156 divided by 13, right? That'll reverse the process. That makes sense. Take 156, divide by 13, and tell me what the answer is. 12, 13, 13? 12? It's 12, isn't it? 130 and 26, yeah. Yeah, it's 12. So that means my guess, that's been multiplied by 12. I divided, which tells me what was being multiplied, right? Then you just try that for those. Say, well, does that work for the other ones? If I go 156 times 12, do I get the 1872? Yeah. Yep. And does it work again? And how about on the first one? Yeah, it cancels the 12, becomes 13. Yeah, it's multiplying by 12 every time. All right, see if you can put it together. What does that mean? And then they want you to write out the function. Just like the last one, right? If you can put it together. So it's exponential, which means it's y equals a times b to the x. This is the b. The b is the 12. The number multiplied every time. And what's the a? 13, right? The a is the number across from 0. Right? A is always the number next to x0. And b is the number being multiplied every time. So this exponential function is 13 times 12 to the x. Everybody see why the x0 thing is true? Now see, what if I took that function? What if you took this and you let x be like 0 in a table? What would you get? 13 times 12 to the 0. What's 12 to the 0? It's 13 times 1. See how you just get 13? Y is 13. See how that number next to x0 is the number in the front? That good?
So would our exponential function be the 13 times 12x?
Yeah, it's this. Yeah, that's our exponential function. All right, you tell me what that one is. Give you a second there. Always looking over here. What's happening from term to term? Yeah, it's just add 5, add 5, add 5, add 5, huh? All right, so what does that mean? Linear, it's a straight line. And we know what that is, mx plus b, right? This is the m, the number you're adding every time. That's what slope is, huh? It's how much y goes up every time x goes over 1. Isn't that what slope is? Rise over run? Now, how do you find the b then? Guess what the b is? The number next to 0. That's the b. 8. Done. Right? Because if you plug in 0, think about if you take that equation, y equals 5x plus 8, and you make an xy table, and you plug in 0, you're going to get y equals 5 times 0 plus 8. You're just going to get the 8. See how that number off to the right is whatever you get when x is 0? So I just go to the table, I go, what's next to x0? 8. That's got to be my b. So the answer is 5x plus 8. It's linear, 5x plus 8. M's the number added. Yeah, so the number added is always the important number. It's the base for exponential or the slope for the linear. And then the other numbers, whatever's next to x0. So we can look at a table now and figure out if it's linear, exponential, or neither, and come up with the equation. We can work backwards from a table to an equation. That's kind of it's a pretty powerful thing we can do. Exponentials, we're going to get a new kind of graph. All right, so generally, how do you graph x? So let me give you the, so what we're going to start doing now is we're going to start building our tool base. You know remember those original 6 functions we memorized? We're going to start adding to those slowly. We're only going to add about 4 more all semester. We're not going to add a lot. But just a few more. We'll do a basic exponential. I think next time, Thursday, we'll do a log. You have the basic exponential look, the basic log look, in addition to the other 6, and then we'll do a couple later. Then we'll do the trig ones at the end, too, so plus those. Yeah, we'll have like 10 basic and the trig by the end. You can graph almost everything. All right, anyway, here it is. A plus b to the x. So of that form. Now, notice I'm doing that different than I did a minute ago. A minute ago, I showed you times there. And I hope I'm not confusing. I'm trying to say this in the clearest way or show this in the clearest way. they can make all kinds of formats. They just so often make the number in front like a 1. So let me write the whole thing. Maybe I should do that. Yeah. Sometimes there's a number for. So there's that number in front. Call it C, call it George, call it Tom, whatever. It's just, I'm just putting a letter there saying, yeah, there could be. This is almost always equal to 1. It's almost always equal to 1. That's why I hesitate to even bother you with it, because it's almost never an issue. It's almost always just 1. And you don't have to worry about it. You can find it easily with the table anyway. So I wouldn't worry about it. The only reason I mainly bring it up is because I showed you a multiplied number in those other table ones we were working with. So I don't want to confuse you and not have. Now, I've also thrown in an added number. That could have been in the table ones also. I just knew they weren't going to do that in the table ones, so I didn't bother you with that. They kept those simpler. But in the graph ones, they will often have an added or subtracted, right? Adding is subtracting. If that's negative, it's suddenly subtraction. Same thing. An added or subtracted number outside of the whole base exponent thing. Okay, that, whatever's out there, added or subtracted, super important. When it comes to graphing, start with this horizontal asymptote. That's the A stands for asymptote. Asymptote line. Exponential graphs always have a horizontal. See it right there? Horizontal asymptote line. They always have a horizontal line either coming down or going up, right side or left side. It's always one of the two sides that they approach, a guideline for them. So in our case, we're going backwards, right? From graph back to equation. So I'm looking at the graph saying, oh, there's the horizontal asymptote. It's y equals positive 1. That's my A. So I go, okay, my equation is 1 plus cb to the x so far. See what I did there? I made the A positive 1 because the horizontal asymptote is the number added or subtracted to the base exponential thing. So plus 1, that's the horizontal asymptote. All right, well then how do we do the rest of the thing? Well, it's just multiple choice on this one. It's going to be more tricky in a minute. I can just help you with the multiple choice. Basically, if it goes up, it's a positive power. Up to the right, I should say. If it goes down to the right, it's a negative power. So look over here at all these and tell me which one has a 1 in the front. Yeah, only H. E's got a negative 1. That's not right. Yeah, well, the answer is H. We're done. I don't even need to mess with anything else. The answer is H. Oh, not negative power. That's not true what I wrote. So it's positive C or negative C, not power. That makes it go up or down. So the multiplier in front being positive or negative. See how that has a negative 5 multiplier on that? So that's why. All right, good enough. I don't like those work backwards ones anyway. I want to just teach you to graph forwards. So let's just go to us because I was so careful about time. All right, so y equals c plus b to the, or I didn't write that way, huh? A plus c b to the x. Okay, can you tell me what the a is? Yeah, that's the asymptote. So 0. Now, is this one going up to the right or down to the right? Up. So it's positive. Some kind of positive c. So which one of those has a positive number and going up to the right and nothing else? It's just A, isn't it? Yeah. Yep, it's just A. There's other things. We got to talk about it tomorrow. The answer is A on that one. I know there's other things, but yeah, we're out of time. We just don't have time, so we'll stop.